Welcome to everybody. Today we are going to be talking about the solution to the GCE Mathematics 2023 paper 3, question number 7. Okay, so the question came and they displayed the diagram. Now we have the question. Okay, so figure 1 shows a uniform rectangular laminar ABCG of side 8A and 4A, a square AGFE of side 2A, and a circle of diameter 2A with BC as tangent at its midpoint H are removed from the rectangular lamina. Find A, the distance from AB and AG of the centroid of the remainder of the lamina. B, show that the tangent of the angle of inclination of AG to the vertical when the remainder of the lamina is suspended freely from G in equilibrium is 124 minus 7 pi all over 52 minus 2 pi. Okay, so that is a question, that is a diagram. Okay, this is how it look like. So we have a rectangle, there's a square and a circle which have been removed, and there's a remaining lamina. So that's all. So let us pass now to our solution. Okay, so let me first display back the question. Let us be analyzing step by step and moving with the question. So solution, we have back the diagram naturally, because you must learn how to work with your diagram. So in this type of questions, there are some assumptions that we make. Okay, so assumptions just like I will let mu be equals to the weight per unit area, which implies that the weight will be equals to the area times mu. That is because we have a figure which is unshaped. Okay, we don't know the masses, we don't know different things to calculate the weight of all the rest. We know that there's a square, we know there's a circle, we know there's a rectangle. Okay, and we are asked to be working with the remainder of the lamina. So I'll just let my mu be the weight per unit area. Okay, so I have the weight to be equal to the area times mu. Now in this type of question, there are some tables of value that you need always to produce. Okay, you need to learn how to produce them. So the table is divided into many parts. We have the portion, we have the weight, we have the distances. Okay, the distances now depend on what the question is asking you. Okay, here they ask the distance from AB and AD, so that's why you have the distance of centroid from AB and distance of centroid from AG. Okay, so AB and AG. Now we have now to calculate what the weight, because my table have the weight. So for this other case here, to have the weight first of all of the rectangle, I need to have lines of segments. Okay, which will be dividing my rectangle into equal parts on both sides. Okay, so we have that. Now the first distances that we are going to be measuring is from the center of the lamina where the lines of segment meet to the point AG, to the line AG. So let us start with AG. So for this case here, we have the line from the center going to AG. What is now that vertical distance or that horizontal distance? So it's a horizontal distance natural, as we can see. So if it starts from the center, so the line AD GC, sorry, the line GC for the rectangle is 8A. Okay, and here now we start at the center going to another point of the rectangle. So what is that distance? It will be half the original length. Okay, the original length of the rectangle, which is 4A. Now the distance of the centroid from AB, sorry. So the distance will be from the center running right up to the line A. It must just be touching the line. Okay, so that is it. It's from the center to AB. Now, what is that vertical distance? The width of the rectangle was 4A, or is 4A. Now, if you start from the middle of the rectangle and you run up to AB, you have run half of it. Okay, it's a horizontal, it's a vertical distance. So you get that distance to be equal to 2A. Now we do same for the circle, the circle, the square, and the remaining body. So for the square, we get the vertical distance from the center of the square to the point AB. That is the distance from AB. And that vertical distance, since the square have a side to be equal to 2A, then it will be equal to A. The same distance from AG. Okay, it will still be the same A, because we are talking about a square. Next, we do for the circle. Now for the circle here, it's a little bit technical. Okay, from the question, we know that the circle have diameter 2A with BC as tangent at its midpoint H. So this point H here is at the midpoint of the line BC. So at the midpoint, so we can draw a line from H to the other end. It will be passing at the center of our rectangle. Okay, so the center of the circle lies on the same line with the center of the rectangle. So for that, how are we going to calculate our distance? Now the distance from the center of the circle to the line AG, what do we get? We get that A is the radius here, so just to another A. So here you are left with what? A from the center of the circle. Okay. Now if you know that the circle have a diameter 2A, you now know, and you know, so that the distance from D to C, the length is 8A. Now what are you going to do? You are going to take 8A minus 2A for the diameter of the circle, and you're going to get 6A. Now they ask you the distance from the center, so 1A is left and the other one is removed. So what do? 6A plus A. Okay, and you're going to get 7A for the circle. Now for the vertical distance downward, it's just like the same, since it lies on the same line on the center. You just take the center of the rectangle. It will be the same distance, okay, because the two centers lie on the same line. Okay, so the center of this circle right up to the point AB, or to the line AB, will just be 2A. Now for the remaining body, that is the remainder, how do we calculate the remaining weight? Okay, so don't forget our weight here is the area times mu. So for the rectangle, you calculate its area, you multiply by mu. For the square and the circle, you do same. Now for the remaining body, you have to first of all add. Okay, you first of all have to add the weight of the square and the circle. Are we okay with that? You add the weight of the square and the circle, and therefore you subtract from the weight of the rectangle, because the remaining portion is there when you remove the circle and the square from the whole body. Do we get it? Okay, so with that, now you get now the remainder to be equal, the weight of the remaining portion to be equal to 28 minus pi into A squared mu. Okay, now to calculate its own distances, from the center of this body to the line AB of the remaining lamina. So there's no more the square and the circle. Okay, forget about the square of the circle now. Now there will be a new distance. But since it's a vertical distance, because we don't know the new distance, okay, but since it's a vertical distance, then it moves along the y plane. So we are going to be calling that distance y bar. Okay, we do same for the distance AG from the center of the remaining body to that point AG, to the line AG, and we are going to get that distance to be x dot dot. Normally we use y bar and x bar, but for this case I will use x dot dot. Okay, so here is x dot dot because it is a horizontal distance moving along the x plane. Okay, so with that, now we pass to the solution. So here we are just going to be taking moments. Okay, because moment is the force, that is the weight, times perpendicular distance. Okay, so here we are to take moment about AB first. So what will be the moment of the rectangle? The whole body. The moment of the rectangle will be equal to the moment of the square plus the moment of the circle plus the remaining moment. Okay, so because if I have a rectangle like this one, I remove a square, I remove a circle. Okay, and now there's a remaining portion. Now what will be the moment of the whole body? It will be the moment of the square plus the moment of the circle plus the remaining moment. Okay, here is just simple analysis. Are we d'accord? Then we pass to the next part. We make the moment of the rectangle of the remaining portion the subject, because we are asked to calculate the distances. Okay, that is the y bar and the x dot dot. That are the distances for the remaining body, as the equation said. So for that, now you replace all the values. Now the moment will be what? Now since we are talking about AB, it will be the moment now of this remainder first, as the formula was stated, because now in the moment of the remainder we have first. So we take the moment of the remainder will be the weight times its own perpendicular distance, that is y bar, from that, because we're taking from AB. Now we do same equal to the moment of the rectangle, that is the weight of the rectangle and its own distance at AB. Same for the square and the circle. We replace all those values and we make y bar the subject. We simplify and we're going to get y bar to be equal to 60 minus 2 pi all that A all over 28 minus pi. Okay, so if we get that now, if you want to verify, you can take a sheet of paper, you simplify. Okay, simplify, let us see if you have the same answer. So that's my y bar. Now with that, now we go to the next part. It's still in A, okay, because we are asked to calculate the distance from AB and AG, of the centroid of the remainder of the lamina. So we now go to the other distance AG. So as I said, these distances depend on what the question is asking you to find. Okay, because they could still ask you to find for DC or BC. Okay, so for this case it's AG and AB. Now here we'll be taking moment now about AG to make now x dot dot day. So it's just the same principle, okay? Moment of the rectangle equals to moment of the square plus moment of the circle plus the remaining moment. We make the remaining moment the subject and we calculate the moments, each of the moment, and we replace their values, okay? So the remaining moment will be the moment of the weight of the remainder of the remainder of the lamina times its distance x dot dot. We do same for the rectangle, the square, and the circle. We simplify. You are going to get your x dot dot to be equals to 124 minus 7 pi all that a all over 28 minus pi. Okay, I hope you are all okay. You can simplify and verify. You tell me if you have a different answer in the comment sections. Yeah. So now let us back to the next part of our equation. So I displayed back the b part, the b equation, and now we have our figure. Okay, now we have that. Okay, with that now the equation says so that the tangent of the angle of inclination of AG to the vertical when the remainder of the lamina is suspended freely from G in equilibrium is 124 minus 7 pi all over 52 minus 2 pi. Okay, so we have this. So the body have been inclined AD to the vertical. Okay, my diagram is not really vertical, but that is a bit how it must look like. Okay, but D is just like the hinge because every all the points are moving, but D is not moving. So it is the body will be moving how below D. Okay, vertically below G. Now, if you get down on this, is the angle they're asking to look. That is the angle. But now they said I was show that the tangent of the angle, not the angle. So they want the tangent of the angle. So we get this of the remaining body. So I've removed the square and the circle just by shading. So they're no more there. We're no more seeing them. So we just see an unshaped figure for the remaining body. So take note, we're no more seeing the circle and the square. Are you okay with that? Now we are still going to be calculating our normal distances. Okay. So we have that for the two bodies. So the distance from here to here and the other distance. Okay, so now we are going to be taking the tangent of the angle of inclination. It will be given by tan theta equals to x dot dot all over 4a minus y bar. Now why am I saying this? Okay, we know that the tangent of this angle will be what? Opposite all over hypotenuse. Opposite all over adjacent. From this inclination, here is our hypotenuse. This line here is our hypotenuse. And this line, the line that must run from here to the center, is our opposite. And therefore, here is our adjacent. Okay, so if we have that now, what are we going to do? We know that x dot dot or x bar is this distance from here to the center. That distance have not changed, okay, because now we have removed the square and the circle, but they still have a portion that is still the same as the original portion, so that distance have not been changed. Now talking about the y bar direction, that is the adjacent now have changed, but from the remaining body we don't have the square and we don't have the circle. Okay, so on the two sides they have been touched. So now what will be that new distance? We first of all know that originally the distance AG was equals to what? 4a. Now if you get 4a and you now know that the new distance of the remaining body of the rest of the lamina was y bar, now how are we going to get down the new distance? The new distance will be 4a minus y bar. That is the original length minus the length of the remaining lamina that we have assumed to be y bar behind. Okay, so now you just replace the value of x dot dot and y bar. You simplify and you see the proof will come out. So we have 124 minus 7 pi all over 52 minus 2 pi as required. So that is all for the video. Okay, I hope you guys enjoy the video very well. So I present myself, I'm Mr. Wilson. Okay, all what I do is to propose to you solutions of GC and mocks, okay, for mathematics, because that is what I think I know more than others. So I thank you all guys for watching. Please like, comment, and share. Okay.